All right, so this one really is more of an exercise in kinematics than it is work and energy. In order to find the work, we need to figure out either the change in kinetic energy or we need to calculate the force, right? So the idea is we want to figure out how much work is done between here and here. So what do I know between those 2 points? Well, I know my displacement between those 2 points is 4.8 meters, right? I know my time is 2 seconds. And that's kind of it, right, for that time interval? Okay? So to find the work done on that time interval, I can either do force times displacement, and I'm happy because I know my displacement, but I don't know my force, right? Or I can try to do something with my change in kinetic energy, which would mean that I'd need to know my kinetic energy at the start and my kinetic energy at the end. But I don't know either of those velocities.
You should just make it start from rest.
Sorry?
You should have just had it start
If
from
it had started from rest, then this problem's a ton easier. But if it didn't start from rest. So what you need to do is you need to somehow use kinematics equations to either find the acceleration or the initial velocity or something. And there's a whole bunch of different ways you can do this. All right? So, Matt.
I have a question about a method.
Okay.
We use quadratic regression to find a positionless function of time equation.
A positionless.
Like, so we find equation for a position of
Okay.
time.
Did it work?
Use that to take the derivative to find velocity. Yeah. Because the force is constant, so the acceleration is constant.
Yeah, right on. That sounds great. That sounds great. Yeah, so there's a whole bunch of different ways of doing this. I guess I'll show you the way that, to me, is the most straightforward, I guess. There are definitely some other ways of doing it. All right, so here's what I guess I would do, is I would set up, because I've been infected by McKeever, I would set up a system of equations. Okay? You want to pick two different time intervals. You want to pick two different time intervals that have the same VI and the same acceleration. So suppose I look at 1 second. Okay, so for that blue time interval, here are the things I know. I know my displacement is 1.6 meters. I know my time is 1 second. And that's it. All right? And then pick a different time interval. Let's do the 2 seconds, the green time interval. All right? And then let's write an expression that relates the displacement to the time. All right? So this one's going to give me displacement equals, oh, sorry. Well, so I'm going to use the 1/2 AT squared equation. All right? So you end up getting 4.8 equals half of my acceleration times my time squared plus VI times time. So if you simplify this, it gives you 4.8 equals 2A plus 2VI. Does that make sense? All right, and then do the same thing over here for the blue time interval. And you get your delta x is 1.6 equals 1/2 times A times 1 squared plus VI times T. So simplify that, and you get 1.6 equals 0.5A plus VI. And so now you got a system of equations. You got two equations, two unknowns. And it's actually not that bad to solve it, right? So use that and solve for either A or VI. Probably the easiest thing is to solve for acceleration, and that'll get your net force. And then just do net force times displacement. Cool? Alrighty. Questions? All right. What else was on?